Hey guys, and welcome back. So I did some more testing, and I think the main reason for this not looking right is the low res number of pieces. So what I'm going to do is I'm going to increase this to 140 to get more things that we can work with. Okay, and let's try. And I also spent some time, I did this test and I found that using the torque, which is what I've been using, to delete the constraint gives us the best results. So I'm going to lower this for now and let's do a test. And it is exploding, so let's check a few things. The rest length, I'm going to lower that to 0. I'm going to reset everything and let's double check, make sure the primitive is set to 0. Okay, cool. So let's go back. Yep, everything is working as we would expect, and we see we're getting some nice bendiness here. Cool. So the main thing that I'm not happy with at the moment is how much splinters we're getting. Everything is very uniform, and I would like to get something where we have a big cluster and then basically a group of pieces that are together and then splinters. So I want to add more variation to this, and Houdini 17 has a very useful node for this. What we can do is we can change the name attribute. For example, for these guys, if we isolate them and then give them the same name inside of SOPs, inside of DOPs and bullet, they will be treated as one object. Okay, so right now they have actually, let's do this. So this is geo, and I'm going to override the name attribute. And I'm gonna say equal would test. Okay, and then we pack that. And let's take a look. So if we check the geo representation, the collision geometry, you see it's one object. Okay, it's treating it as one object. That's because of the name attribute. So the RBD, there's a new node in Houdini 17 that we're going to use. It's called RBD cluster. What this does is it changes the name of the geometry. So if you look at the name here, it's grouping the geometry based on names. And let's put down an exploded view. And I don't want it to auto detect, I want to use the existing attribute. And now we can see the pieces, the geo is being grouped. So let's change this to 5, 5, and 5. Okay, and let's take a look at the exploded view and see now we have bigger pieces as well as small and fine pieces. And with this, I'm allowed to increase the number of the number of fractures, because we're going to have less points at the end. We're going to have less geometry. And that's what we're going to use with the system now. So let's continue. And with the RBD cluster, we have to plug that before the connect adjacent because it changes the name attribute. And everything is the same. So let's do that. Let's take a look at the result. And what I'm aiming to fix is the uniformity of the splinters. And now it's much faster because we have less geo as well. And some pieces are falling. We'll fix that in a bit. And let's do, all that is fine. Let's go here and let's increase this to 15,000. And I'm actually removing the primitives. I think it's still, there is an issue with changing the name, so I'm simply deleting them for now. I mean, it should work. I don't understand why, but for now, I'm just gonna stick to this. Cool. So we're getting everything we need. And the last thing is I want to increase the number of constraints. So right now we're connecting the the geometry using this method, which connects the centroid. This is not going to give us enough constraints to give us the nice flexi motion that we're looking for. So I'm going to change this to points. And if we take a look now, sorry, not points, adjacent points. No, which one? Sorry, adjacent pieces from points. Yeah. And let's increase this to 1, maybe 0.5. And I'm gonna increase this to 2. This is gonna give us a lot more constraints, and it's gonna give us better motion. It's gonna get slower for sure, but this is really needed for to get realistic wood deformation. Okay, let's play. Let's hit play. Maybe it's too much constraints. Yeah, it's definitely too much. I mean, for this, to be able to run it real time, I think it's too much constraints. But let's wait for at least this part to solve. We'll wait up until this section here. So the next thing I want to change is there is few controls in the constraint network, in the cone constraint, one called constrained up axis, constrained twist axis, and another one called goal up axis and a goal twist axis. And they are set to X and Y up at the moment, and we're going to change them to match the topology of the geometry. And what this allows us is to get more accurate bending between the constraints. So right now they're rotating along specific or a uniform axis, which works, but we can get more realistic motion if we tell this geometry how it can bend and what axis it can bend along. So we're gonna add a few things to help with that. And as you can see, the structure as well is not falling anymore. That's because we have enough constraints that holds it up. The workaround for that would be to add another constraint, a glue constraint that holds everything together, and we use a weak strength there. So let's pause. Let's play these guys. So here, see that nice splintering there? Yeah, this is going to work pretty well. The other thing I may change, or I'm gonna change, is I think the pieces are too long. The shards, the splinters are too long. So I'm gonna go back to the Voronoi and fix that. So let's check here. We're scaling it down by 0.01, 0.05. I'm gonna double this 0.1, and this is gonna make the splinters length 50% shorter. And I'm going to reduce the number of constraints to 0.5, 0.25, and the max connection is 1. I think that's enough for now. And let's dive back in. And let's hit play. And remember, we're only simming one block at the moment. We have 6 copies of this, so it can get quite slow to run this, to run and solve all this, and we have to be careful with how many constraints we need. But again, I mean, to get realistic motion, we have to have this much cone twist constraints to get the realistic motion, because what we also want to get is the flexing. So for example, if this piece gets pushed out, this is going to have a lot of stress and deform, and this also, so we're going to get all this motion propagating with a cone twist. So even though these are still, they're actually active and waiting. Yeah, I like it now. It feels much more solid, and the fracturing is working pretty well. Yep. So I'm gonna let this sim for a bit, and then we're gonna continue in the next video and improve this further. Thank you guys for watching, and see you in a bit.